Hi, everybody, and welcome to the PASCO Probeware webinar for grades 7 and 8. Just a couple housekeeping notes before I introduce myself. I just wanted to let everybody know that your mic is muted for now, but I will open it up at the end of our session. But if you need to communicate with me, feel free to do so in the chat window. You'll see that on the right side of your screen. And you can type a message either to the entire audience or just to myself by using the drop-down menu, or to another participant. If you don't see this menu that you can see on my screen right now, you can hit the orange arrow and that should expand the entire menu. That might appear and disappear throughout the webinar. So that orange arrow will bring this menu back up. And in case you have to leave, we are recording today's session, and we also are joined by Christine Christensen from the Department of Education, and she will send a link out, or rather she will make a link available to you. If you want to chat, type a chat, please, Christine, so that people know you're here. Thanks. My name is Barbara Puglisi. I work for PASCO Scientific, and I'm here in Northern California today. It's 11:30 a.m. on my side. I just type in the chat window, what's today like over there in Nova Scotia? I know you're in different parts of Nova Scotia. It's a rainy day here in Roseville, California. It's about 57 degrees Fahrenheit. Here's what we're going over. Oh, it's gray and cloudy. Some snow. Okay, here's what I hope to cover today. It's kind of an ambitious agenda, and you may have gotten an email that if you'd like to participate, you're welcome to, and I had asked to bring sensors and some equipment, and I'll talk about that. Or you can just watch and learn. It's your call. The first thing we're going to look at is the temperature sensor. And I'm going to share my webcam. Give me 1 second to do that. Okay. You should see two screens now. There's a dividing line that looks like a horizontal bar, which you can hover over and drag up and down to change the size of either screen. You should see a view of my temperature sensor in a beaker of water. So this is the first sensor we're going to talk about, and we're going to use the SparkView software, which I'll open in a moment. SparkView software is available on the school-provided devices when you or your students log in with your GNES-PES account. And if you have an iPad or Chromebook, etc., here's the information that you might be interested in. If you have an iPad, if it's not already installed, SparkView software is in the App Store. On the Chromebook, it's already installed, but take a look at the camera. I want to show you this device. This is a USB adapter, otherwise known as a dongle. This is very important. If you have Chromebooks for your classroom use, make sure that this device is plugged into the USB port when you use these wireless sensors for the rest of this school year, or until you're sure that all of your sensors are updated. And I will go over how to update your sensors, or how to know whether or not they're updated in a moment. If you have a Windows or Mac computer, you can download, and this is true for your home computer as well, you can download these licensed software from this link. And by the way, this PowerPoint will be made available to you, and I'll give you the link to that in a moment, so you don't have to write things down unless you want to. But you can download the software here. And if you have a smartphone or tablet, Android, just go to the Play Store and the app is free, and that's for your personal devices. The next thing that we'll cover after the temperature sensor is the conductivity sensor. We'll take a look at water quality testing and also look at some different displays in SparkView. I have a question I see. If you want to see the sensors only, you can grab the horizontal gray bar. So look for a little divider between the two screens. Grab that bar and drag it either up or down so that the screen that you prefer to see larger is bigger. Is anybody else not seeing the line in between the two screens? If you don't see the line, try hovering. Well, first let me ask the question. Do you see two screens? One is of a PowerPoint and one is of a temperature sensor inside of a beaker. Okay, if you see the two screens, then take your mouse, or if you have a touch device, I don't think this will work, but hover over the dividing line, whether it's visible or not, between the two screens, and look for a double arrow when you hover over that. Okay. And then when you hover over that dividing line and you see the double arrow, hold down your mouse and drag either up or down to make that screen bigger. I'm not sure why somebody's seeing only the PowerPoint, but what I can say is in the recording, it will show both screens. So I apologize if you're not only seeing one, but you will be able to see the second one in the recording. Pressure sensor is a very useful sensor for helping students see the invisible. All of these sensors are good for helping students visualize data, but especially the pressure sensor for creating a mental model of the particle theory. And in 7th and 8th grade, that concrete view of maybe a balloon blowing up, something that the students are used to, we have to start taking that into the more abstract view of the particle model. And this sensor really helps you help your students build a mental model, and I'll go over some activities that help do that. We're going to look at the carbon cycle with the carbon dioxide sensor, and while I'm walking through these activities, I'll give you a few new pointers in SparkView, a little bit at a time, and I'll try to keep my eye on that chat window. As questions come up, do type them in there, and if you do have any tech issues as well, let me know about that, and I will try to address that. Okay. I probably will run out of time towards the end, but I'll give you a few tips about the light, voltage, and current sensors if we have time, but I haven't designed any hands-on activities around these sensors for today. I'll also point you to some online resources, both from PASCO and from AVA. First thing I want to talk about is that firmware update, a software update that goes onto your sensors. Why do we do this? Well, your sensors, every time we send out a firmware update, the software will automatically say, hey, do you want to update your firmware? And what that means is software goes into the electronics on the device. And sometimes that means it's making the performance better, or often it's adding a new tool to that sensor that didn't used to be there, and now you've got more capability in your sensor. So you do want to do this firmware updates when they come up. On Chromebooks, again, I can't emphasize enough, make sure that this is plugged in if you're using a Chromebook, and make sure that's true all year long. I'm going to talk briefly about doing a firmware update in a moment. If you're using, let me show you a picture of what it looks like in SparkView. So if you brought equipment to kind of follow along in today's webinar, please open SparkView. When you open SparkView, you should see this screen. This is the main screen. Okay, so if you're following along, you can open SparkView. And if you haven't opened SparkView in a while, it might be doing an update. So while that's happening, I'll talk about what we're going to do next. Okay, when you do a firmware update, some sensors, like the temperature sensor, do not have a USB plug on them at all. It's battery only. So your only choice is to do the update through Bluetooth. But if you have a sensor like the voltage sensor that has a USB port, it's rechargeable, I recommend doing the update with the USB plugged in. and the dongle if it's a Chromebook, because this works much faster. It's faster to transmit data through wires than it is through the air on firmware updates. Okay, so, all right. You can skip a firmware update, but it will keep asking you every time you open SparkView and you connect that sensor, it's going to keep asking you to update that sensor. So eventually you should do it. Today, though, if you are prompted to do a firmware update, I'm going to say skip it just for today, just so that we can get through the webinar quicker. I have a question. Will one dongle work for all sensors, or is a different one needed for each sensor? It will work for one device. So if you are using one Chromebook, you need one dongle into the Chromebook, or in a Windows 7 and older Windows. I think the newest version of Windows is you don't need the dongle, but older versions of Windows you do need the dongle. Once you plug this into the device, you can connect as many sensors as you want. So up to 3 or 4 sensors on the Chromebook with one dongle. And when you are prompted to do the firmware update, you will see a screen that looks like this. We'll get to the screen in just a minute, but this is what it looks like when you need an update. You connect a sensor and it says this. Please, for today, please say cancel. In the future, go ahead and do the update again with the dongle in there if you've got a Chromebook or older Windows. I think it's older than 10. It's just a safe bet to just have it in there if you're not sure. Okay. Christine says, you can open SparkView on your Chromebooks from the apps. Be sure you're logged into the Chromebook with your GNS PES account. If you don't see the SparkView app, you may need to wait a moment and it should pop up. And the reason why it would take a while to pop up is because it's downloading the software if it's the first time you've opened it. And it's quicker after the first time you open it. Okay, we're going to connect a sensor. So if you're following along, you get this is just a beaker with tap water in it. To turn on the sensor, hold down the power button, long press. So it's not a quick press, it's a long press, it's about a second. And you'll notice that the Bluetooth light is flashing red. Let me see if you can see that. Okay, so it flashes red. If you see this light on the right side with the battery flashing, that means you have a low battery. So hopefully you just have the red flashing light. And then, in order to connect the sensor, you're going in SparkView to go right into the middle, like you're hitting a target right in the center, go to Sensor Data. This is where you connect sensors. And here's that menu. If you have a sensor that needs a firmware update, you're going to get this picture. Please say cancel this time, but after the session, go ahead and update them. And you'll notice that you have a sensor on the left side and it has a number and it says temperature. You can imagine a dozen of these on at the same time in your classroom. So your students might be wondering, well, which one's mine? Which one is my sensor? Well, first of all, the number on the sensor matches the number in the software. And second, we have what's called proximity pairing. So the closer the sensor is to the device physically, it'll go to the top of the list. There may be 4 other sensors down here, but the closest one ends up on the top. So there's 2 ways for the students to know which one is theirs. In order to connect, you simply touch the word anywhere in that bar, and it says that it's connecting. I'm kind of far away from my Bluetooth or from my computer right now, so it took a while to connect, but this is what happens when it's connected. That middle window expanded and temperature check mark, that means I have a temperature sensor connected and I'm ready to collect data. Then where do I go from here? Okay, the easiest thing to do is to look on the right side at these templates. And for today's activity, we're going to choose a graph. I want to see a graph to collect some live data. So I'm going to click graph, and it automatically builds a graph for me. And the units for temperature are in degrees Celsius. I'm pointing to the left side. Can you guys see my mouse cursor? Or is that too teeny tiny to see? I'm pointing at the temperature button on the y-axis right now. Okay, good. I'm glad you can see my mouse. All right. So let's say that you don't like the units Celsius. You can change those units to Fahrenheit just by clicking that button. And this menu pops up on the right side here. Here's temperature. I want to change the unit, so I just click that unit and I can change it to Fahrenheit if I want. or I can select it again and go back to whatever unit I care about. So I'm keeping it at Celsius right now. Notice there's no data, not until I hit the start button down in the bottom center where it says start. So you hit the green button and it starts collecting data. And the temperature is stable as it should be because I put this sensor in here a while ago. But what's going to happen if I take the temperature sensor out of the water? Would you expect the temperature to go up or down or stay the same? So here's an activity you do with your students. Ask them, make a prediction. Should the temperature go up, down, or stay the same? So there's a verbal prediction you can make, but the software I'll show in a moment can help you make a physical prediction on the graph. So I'm going to take out the probe from the water. Hopefully in your head you have a prediction, and we're going to see if you're right or wrong. So now the sensor's out of the water, and look what temperature's doing. Temperature is going down. Okay, well, why is that happening? Does it mean that it's really cold in the room that I'm in, or does it mean that this water in here was hot? Well, I don't know. It was just in between 21, just around 21 degrees Celsius. So here is where you can teach a little bit about the particle model to your students. They can take an observation they made. Temperature's dropping when I take the sensor out of the water, and you probably can't see. I'm going to bring the probe up to the camera. It's wet on the end. Okay, I'm going to take a paper towel and dry off the end of the probe. And I want you to watch temperature change as I do that. So I'm drying it. I dried it off. It's dry now, and look what temperature did. Suddenly it's not getting cooler anymore. It's starting to warm up. Is that because I touched it, or was it because of the paper towel? Well, a little bit of that. But actually what was happening is evaporation. Evaporation is a process where energy is collected by the liquid in order to turn into a gas. When the sensor was in the water, I was touching only liquid. As soon as I pulled the sensor out, I started evaporating. I started losing. The higher energy particles are leaving, and whatever's left behind, the liquid, has less and less and less energy as those gas particles evaporate. So we have visible evidence of the particle theory that energy was leaving as evaporation was going, and energy was going away with those vapor particles, water particles, and whatever was left behind on the sensor was just getting cooler and cooler until the water slowed down because less and less water was available, and then finally I dried it off, and now it's warming up to room temperature. So I asked to make a prediction verbally, but there's a tool in SparkView that you can have students make a prediction before they collect any data, and that is in what we call the graph toolbar, this gray bar just beneath the x-axis, which is, by the way, collapsible. So if I touch that first square, open and close, it could toggle it because it kind of blocks the x-axis label. Here is to the far right, the second button from the right is a picture of a pencil. That is my prediction tool. So your students, you might have asked before you started collecting data, you could have said, draw on your graph what you think temperature will do. So they might have drawn an up line if they think it was going to go up. Or if they thought it would stay the same, whoops, let me turn off. In order to get rid of a line, you have to turn the tool off and then turn it back on to redraw. They might have thought it stayed the same, or they might have thought it would, whoops, just showed you another feature on accident, or they might have think that the temperature would go down. If you want that line to stay on there, you have to click the Done button, and it will stay there while you collect data. Okay, now what's going to happen if I have one sample of water versus one sample of rubbing alcohol, otherwise known as isopropyl alcohol? Here's another thing you can show your students is how do different substances behave under the same conditions? What do the differences in how a molecule is structured or the identity of a substance, what does it have to do with how they evaporate? So let's compare water again. I'm going to hit the start button again, and you notice that run 1 disappeared. I'll show you how to get it back in a second. So there's the water The first sensor I took out from water. It's interesting that it's increasing. This is kind of cool. I've never seen that before. Huh. Let me try that again. So it is not decreasing. I think we broke physics here. This should be decreasing. Oh, you know what happened? I didn't connect the sensor. That was totally me. So let me connect a new sensor. All right, so when you're already in SparkView and you want to connect a new sensor, you don't have to go all the way back to that first screen. Here is a Bluetooth connecting button right here. It's the Bluetooth symbol. Right in the middle of your experiment, you can add new sensors. So I didn't need to change the dongle or anything. I could go to this Bluetooth button here. I can turn on the sensor. There's the original sensor I was using. I don't need it anymore. So I can hit the X button to get rid of that sensor that I don't need anymore. And now you can see I've got a few sensors. I'm going to turn on the second sensor at the same time. And now it's really important to know which one's which. So I put a number 1 sticker on my sensor to help me figure out that number 693 is number 1. If I connect it first, the software will think it's number 1 also. And my second sensor is the one that ends with 998. So I'm going to connect it next. And this is what your students, similar to what your students will see if you have multiple sensors going on at the same time in the class. And I don't need the third sensor, I only need these 2. If I wanted to, I could keep it connected. I'm going to hit done. And if I want a run to go away because I made a mistake like I just did, all I have to do is go over to the legend and unclick that box to make it go away. And to make it come back, I could just check mark it again. And by default, automatically, the runs are hidden as soon as you start a new run. So let me start run 3. Okay, I want to see 2, but before I start the run, I want to see 2 temperature sensors at the same time. So how do I do that? I have to add an axis. I have to add another thing to my y-axis. So I'm going back to the menu and I'm going to hit this Add Y-axis button down here. And this is a useful time for when you want to make direct comparisons like we are today with water versus alcohol. So you notice when I hit that button, that Add New Y-axis button, it says Select Measurement. I have to tell it what I want there on that second Y-axis. Also, back here on the first Y-axis, that's actually the old sensor. It still thinks that it's the old sensor. I didn't tell it to change anything, so I need to tell this axis to be temperature sensor 1. And you only need to do this if you have more than one sensor connected. And I need to tell this axis to be temperature sensor 2. And all I had to do was click the button to get the menu to come up. Okay, and now when I hit start, I would expect to see both temperature sensors at the same time. Okay, I'm going to hit start. And I have 2 lines of data here. And it might be confusing because they should be about the same temperature, and they actually are. But notice on the left side, the range goes from 20 to 22. On the right side, the range is a little different. Here's how to fix that. I'm going to stop collecting data. I'm going to hit this button in my tools, this button that makes the ranges the same. In other words, it's called Align Origins. So now my range is the same, and I have directly comparable data. And as expected, the 2 runs of data are about the same temperature. So now I'm going to start, and I'm going to compare the 2 rates of evaporation between isopropyl alcohol and water. I'm going to see if there's a difference here. I see one is very quickly declining and one is kind of slow, more slowly declining. Okay. And just for the sake of time, I'm going to stop. Now, that's really tiny and it's hard to see. There's a tool here in the toolbar called Scale. That is, we put it right next to the toggle button, because it's a really important tool to make sure that you can see all of the data. Let's hit it. That's much more dramatic and much more easy to read. Now, how do I know which line is which? The first line, here's Y1 in the legend. The first line, the blue line, is Y1. In other words, this temperature sensor 1. So the water had a different rate of evaporation. It was slower evaporation than the alcohol temperature sensor 2. And I know that this data belongs with this sensor because the second Y2 is that color. Okay, here are some analysis tools on how to work with these data. So it's important first for students to understand that trends, they increase, decrease, or stay the same. But you also might want them to do a little bit of calculations. Maybe you want them to know the rate of change, the slope, or how much did the temperature increase or decrease by. Here are a couple of tools. The first one I'm going to show you is down here by the orange hand. Right now, it's showing the toggle or move mode. So that means if I click inside of the graph and I hold down, click and hold, I can move the whole graph anywhere I want, left, right, up, down. And if I get totally lost and I don't know what happened to my data, all I have to do is hit scale to get back to where I was. If I want to know what was the change in time or the change in temperature, I can go to the statistics tool in the toolbar down below the x-axis. So if I hit that stats button, I have all of these choices. Minimum means the lowest out of all of the data. Maximum the greatest. Mean is the average. Standard deviation count and area. You're most likely not going to use in middle school. What if I want to know the rate of change? Okay, right now you can see that there's a red box around the magenta colored line. So that means anything I do out of these tools is going to apply only to that magenta colored line. So if I hit this tool right in the middle, which is a linear fit, it shows me the slope or the rise over run, the rate of change. M, your slope, your rate of change is negative 0.134, which means a drop of 0.134 degrees Celsius per second. But notice that it's taking all of the data for the whole run. I've got some yucky data over here on the right that I really don't want to count, and I've got some yucky data over here on the left that I really don't want to count. I'd say yucky because while it is good data, it's not useful for the evaporation time. So what I can do is select only part of the run to analyze. And I can do that by going to the orange hand tool and changing it to the select tool. Now I have an orange rectangle. If I click and drag, I can select just part of the data. And I can apply a slope, a linear fit, just to that part of the data. And you'll notice that that's a much better straight line. If I made a mistake and didn't grab in the right place, I just have to grab the handle and notice how the slope changes and moves with whatever my selection is. So I can fine tune as needed. If I want to know maybe just the change in temperature or just the change in time, I can use a coordinate tool button. That button is right here. It's the third button in. If I click it, it tells me the information for just one point of data, and I can pick up the square that it's pointing to and move it up or down, and it'll tell me at an instant what is the time and temperature. But if I want to know the change in time and temperature, there's a tool for that as well. If I let go of that box, there's this delta button. And if it goes away accidentally, I can bring it back by just clicking the bubble that has the information. So if I hit the delta tool, now I've got two of these boxes. There's one on the left and one on the right. Let's say I want to know the change from that first point there down to the end point there in my box. And now I've got a delta Y, so the change in the vertical was 2.8 degrees Celsius from here to there. And the change in the horizontal, the delta X, is 18.5 seconds. I've gone over a lot of stuff in a half hour, and so I'm just going to pause and see if you have any questions in the chat box. Okay. While I wait for questions to come up, I'm going to give you some other ideas that you can use with putting 2 sensors at once, or maybe just one sensor at a time. Maybe you want to know if there's a difference in the temperature of your fingers versus your wrist versus your elbow, all the way up your arm. Is there a difference in 2 different students? Or maybe one student was exercising and the second student was not. There's another use of 2 temperature sensors at the same time. Another activity you can do is grab 2 test tubes with 1-hole stoppers in them. Fill one up. Use a bike tire inflator. This has carbon dioxide in it. You can get these at any bike shop or Walmart even. And put just 1 or 2 seconds worth of carbon dioxide into the test tube. Seal it up right away. Put a temperature sensor in there. And actually, it's a smart idea to put the sensor first into the 1-hole stopper and then put it at a distance reasonable. Hold on. It's difficult to get that sensor in there. Okay, leave at least a couple centimeters out. Close it back up and put 2 of these together, one with CO2, one without. One will be your control. Set them in the sun for a while and see what happens with the temperature over time with carbon dioxide loaded air or just regular air to do a study of greenhouse gases and the effect on temperature. A question: are there any instruction sheets to give students to show them what the tools mean, kind of like a cheat sheet? Yes, Sadie, there is a cheat sheet, and let me show you where to find that. So I'm going to real quick go back to the PowerPoint, and I'm going to fast forward to the very end. And this PowerPoint, whoops, this PowerPoint is in a resource folder that I'm giving you. So there's a link here that says Files from Today's Training, and it's this web address. If you click that, here's what you'll see. It's a Google Drive with files that Christina shared, and what's in there are 3 folders and a movie from a prior training that I did in Nova Scotia in February along with Glenn Starkey. We have all kinds of goodies in here for you, experiment ideas, and also cheat sheets. Today's files it's really just the PowerPoint and an agenda. So you'll find the PowerPoint in the webinar folder, but the cheat sheet is in the resources folder. So if you open resources, there is this document that says SparkView 4 Quick Reference. And if you open that up, it's a giant cheat sheet. Let me get that open for you. So here's a giant cheat sheet. It's got what the main menu does, and this is useful for yourself as well. There's a bunch of pages on here. Here's the menus, which we haven't got to yet, but in case you forget what each thing does, which there's a lot of things to look at. So yeah, there's menus, there's that screen where you connect and what everything does there. So you can feel free to share this with your students. If you want the original, it's in an Adobe format, so feel free to email me. My email address is in the PowerPoint, and I'll send you the original file so you can modify and make this smaller for your students if you like. But just for space sake, it's in a PDF form. I'm going to check the chat again. Okay, so Christine says she will send the link to the folder that I'm showing you. And I will also put it in the, I'll post this link in the chat window. Let me get that up there real quick. Give me 1 second. This is a shortcut to the same place that Christine will be sending you. It's just a short one. If you'd like to do a private message, just look right below the chat window. It says all entire audience, and there's a little drop down. You can pull that down and then just check mark the person you'd like to send the message to. Okay. So because there's probably a lot of interest in what's in here in this folder, I'm going to real quick talk about more things you could do with where you can find more things to do with the temperature sensor, and I'll go on to other sensors in a moment. So if you click that link, you'll get to here. Development time activities in this folder. quite a few ideas for quite a few different sensors. Some other, this document at the very top, the copy of PASCO sensor extension ideas. These are just a brainstorm of what you can do with individual sensors, and everything else are actual lab write-ups you can share with your students or modify for your own use. Some of these are for the conductivity sensors, some for carbon dioxide, some for temperature, and so on. So that's what's in that folder. In the guided activities, this was, we walked through a few activities in the training back in fall. And this is just was a folder to separate the things we did live versus the things that, the activities that people did on their own time. But this is also a good resource for ideas or fully written up experiments that you can share with your students. And again, the resources folder, that was the first folder I showed you. And webinar, this is where you'll find the PowerPoint from today. This movie, somebody had recorded the directions on how to put the wind turbine together in your renewable energy kit. Towards the end of the webinar, I'll show you where to find more resources for that particular activity set. Okay, I'm gonna go back into SparkView. And we're gonna move on to the conductivity sensor. Were there any questions about the temperature sensor before I move on to a new sensor? While I'm waiting for questions to come up, I want to point out that on the temperature sensor, the sensitive part is just that last centimeter down here. So that broadens, you don't have to have the whole stainless probe into whatever thing you're testing. It's just that last centimeter. So that might give you some ideas of the freedom that you have with using this wireless sensor. It's really not that much. You can save liquid on liquids that way. Okay, I don't see any questions for the temperature sensor, or if they're coming up, I'll address them when they do pop up. Now I'm going to disconnect the temperature sensors and add a conductivity sensor. And the easiest way for me to do that is just to let the experiment self-destruct. And the self-destruct button is at the top left where it says main menu. It's the hamburger menu with the 3 horizontal lines. So I'm basically going to go back to the main menu. When I click that menu and I select the top option, Start New Experiment. If I start new experiment, it asks me if I want to save. Yes, you can save the lab, but you don't need to this time. So I'm going to say, no, I don't want to save the experiment, and I'm back to that main screen. Okay. The way that we connected the sensors was that center of the target button right here. And right now I have these 2 sensors connected, the 2 temperature sensors, but I don't need them anymore. I'm done with them. So I'm going to expand the menu on the left and disconnect them because I don't need them. And you'll notice now they come up again, but they're just there as choices if I want to connect them. I don't need them, so I'm going to clear up my lab area and grab my conductivity sensor and turn it on. And there it is. And I click to connect. And set it down. And now it shows up in the middle as being connected. When you have, you'll notice that there's another option here, total dissolved solids. Most likely you're just going to be using the conductivity measurement. These are really the same thing. But let's say that I really don't want to use any of these templates. These don't really satisfy the need, the way I need to see the data. So I'm going to get out of this menu by hitting the cancel button on the top right. A question came up before I move on to leaving this menu. The question is, where will the experiments be saved to? That really depends on your device. So if you're on a Windows computer, like I am, you can save it to your, it'll take you to the file manager to save like a normal file somewhere, like maybe in your My Documents, and the same is true for Mac. It goes to your file manager. If you're saving on a Chromebook, it's going to go to the Downloads folder. If you're saving with an iPad, well, for an iPad, you would have to do what's called sharing. And I don't have an iPad to show you, but I can point you to a video resource on how to save in the iPad. Also, recently with smart devices, there's the ability to save to your cloud, into a cloud drive if it's connected and installed on your device. So if you use Google Drive, you can save there on your, that's true for any device where it's installed. Okay. So I'm going to, oh, and another, by the way, for saving, if you don't want to save the experiment and you just want like a screenshot of the data. That's the way I would use it with my students. I just wanted to see the data and I wanted them to talk about it and analyze it in their words. I just have them do a screenshot, send it to a Google Doc. So screenshot to a Google Doc, that for me, that was my preferred method of saving digital labs. Okay, so I want my own custom display. I really don't want these templates. I'm going to hit the cancel button. My sensor is still connected and I can tell because this Bluetooth button is flashing green. So I know I'm still connected. I'm back in the main screen. I'm going to go again to the middle and I'm going to click this button, Build New Experiment, to do a custom build. And it tells me I can select a layout. So this looks a little bit like the templates that were on the right to begin with. And each piece, each gray piece, will give me a different display if I want. I am going to pick the third one down. And the reason why I picked that is because I want two different displays. I want a digit display, that's the 1, 2, 3, and I also want a bar graph, which is the best way to see conductivity measurements for the type of investigation I'm doing right now. So I clicked the bar graph. And the cheat sheet, by the way, tells you what each of those icons mean. But SparkView is asking me what I want to display. It's saying to select a measurement. And there's an orange box around it to remind you have to pick something. So I'm going to click it, and out pops this menu. I'm going to click conductivity. And the same is true on the graph. It wants to know what I want to see in the graph. So I have to click the button and select the sensor for the display. Okay, I'm going to hit start. And my conductivity is not in any, it needs to be in a solution. And these electrodes need to be covered in solution in order to get a reading. So let's just check out the conductivity of some tap water. 54.3 microsiemens per centimeter. The unit means nothing to a middle school kid. Really, it's just the number and comparing greater or less. That's not terribly too much. Dissolved solids, and what that means is like ions, like calcium, sodium, and so on. So it's a kind of a measure of hardness of water as well. All right, when I connected the sensor, it did something called switching to manual mode on the bottom left. You might have noticed it says manual and you have a check mark. So that's different than before. Before we had data automatically being collected. Now in manual mode, I have to tell it when I want it to collect data. So I'm reading it. I want to keep this piece of data for my measurement. I'm going to click the green check mark to say I've got my measurement for that water sample and I want to do a second sample. So you notice when I click the check mark, I got a second bar, and that second bar is live, it's moving. So let me get a different sample. And by the way, when you move to a new solution, you should get a rinse bottle and some distilled water and clean the probe in between solutions. And this is just good lab practice. And also make sure that you don't contaminate your samples. I have some pond water that I collected yesterday before it started raining from right here at PASCO. I'm just going to see what the conductivity is from pond water on our campus location. It's much lower than tap water, so there's not too many dissolved ions in our pond water. I'm going to check that to keep it. And then what I did is today it's raining, so I went back out to the same pond and I wanted to see if there's a change in conductivity, because if there is, then that could mean that there's a lot of erosion of the land around the pond and some ions are dissolving into the water and changing the conductivity when it rains. So here's something you can study with your students is, how does conductivity change when there's changes to the body of water? Like maybe there's, oh, it's a windy day and it's pushing water where it doesn't normally go, or it's raining, or maybe you're near the tidal bore, and how does the conductivity change over time as the bore comes in? Here's my reading for the second day on the same pond. It's a little lower and a little lower. So to me, that's such a small difference that it's about the same. So I hadn't seen this result before. I came in, I was curious to see what would happen, and it's about the same. It's a little lower, and I would assume if I continue to see this trend of a little lower every day, if it rains tomorrow and I collect another sample, then and it's lower again, then maybe it's just getting more dilute and I really don't have ions dissolving from the soil into the water after all. Or maybe I'm on top of granite, and granite or sandy areas don't allow much dissolving of ions and into the water when it rains. So maybe the conductivity doesn't change because of that. So there's all kinds of questions that can come up from seeing this data. I'm going to hit stop. And bar 1, bar 2, bar 3, they don't really tell me much about the information that is contained in this bar. So I can rename the x-axis variables by clicking the bar. If I double click the bar, this menu pops up, and instead of bar 1, I'm going to call this tap water and then say OK. And bar 2 was pond water day 1. And bar 3 was pond water day 2. If I want to know what the values were, I can hit the button that says 1, 2, 3 in the menu just below the x-axis, and it shows the values, and hit scale so I can see the numbers. It shows the values just above the bars. I'm going to pause here for questions. I'm going to check the chat window in a moment and set up my next experiment. Any questions on conductivity or anything else so far? Okay, and I know there's still maybe questions coming or not, and I'm super behind schedule because I always have an ambitious agenda. We're going to move on to the pressure sensor next. Any guesses as to what that is in the camera view? So what I've got there under the camera is I took a pressure sensor, and I don't have a plain one to show you because my second pressure sensor is inside. There's a balloon over it. So I took a pressure sensor, I got a balloon, and I opened the heck of it like this. So I took a balloon, I worked my fingers so that I could open the balloon like this, super wide, and I got a second person to help me shove the sensor into the balloon, and then I pulled the top over the opening. And make sure that the opening is at the top like this so that it can read without getting blocked when we do an activity with a balloon. So here's an activity that can help your students get an idea of how they can visualize particles and what they do when you change a physical property of them, such as pressure. So I'm going to blow up this balloon, and we're going to look at the changes in pressure while we blow up a balloon. But I have to remember to turn on the sensor before I blow up the balloon. So the power button on the pressure sensor is, this one is this black button right next to the USB. So I'm going to turn on the pressure sensor. I can turn it on through the balloon, and you can see that the red light, the Bluetooth light, is somewhat visible through the balloon. You can barely see it there, but it's flashing. And now I can connect it to SparkView. All right, so I'm going to self-destruct this experiment. I go to the hamburger menu, and I start a new experiment. And no, I don't want to save the changes. I'm going to connect the new sensor by going to Sensor Data. I want to disconnect my conductivity sensor, but I do want to connect the pressure sensor. And this time I'm going to go straight to a graph template because that's suitable for the data I want to see. So I click Graph. And notice this time it says periodic and not manual, and I have a record player looking symbol. That means it's going to collect data automatically instead of me having to click the check mark. Okay, so I'm going to blow up this balloon in the background. Christine knows that I hate it when people watch me blow up a balloon, so it's a good thing you can't see me. I'm going to start collecting data and watch what happens. Well, actually, I think you might have to look and see what happens because I want you to make the relationship of what happens as I'm blowing up the balloon to what you see in the data. So I'm going to switch cameras. And the view should change in a minute. It's not wanting to come on. I know you have a black screen right now. Awesome. Okay, well, I guess you can't watch me blow up the balloon, unfortunately, because it's enlightening. Still can't see it, right? Try this again. Interesting. I'm not sure why it's not working. Okay, well, I guess you can't see me. So I will try to switch back to the other camera, and I'll try and get the balloon in the view. Okay, here we go. Okay, so keep an eye on spark view while I blow up the balloon and see what happens to pressure. Woo, it popped. Okay. Sorry about that. That wasn't supposed to happen, but actually it was kind of cool because we have some interesting data to look at now. I'm going to stop collecting data. So when I just had that sensor in the balloon, it was just stable. Then I started inflating the balloon, and look at what happened to pressure. Big increase at first. Big change in pressure, and then smaller change, and then smaller change as I was blowing up the balloon. And then it popped. So it dropped. When we were measuring pressure inside of the balloon, initially we had a big increase in pressure. Keep that in mind. Now there's a tool in SparkView that helps you identify what happened at different stages of data collection. I'm going to use the ability to move my graph paper over to the left because that's really data I don't need on the left side. And I'm going to expand the x-axis by clicking the numbers with my left mouse button and dragging. Remember, I can also select specific data by using that rectangle button, the select tool. If you use the annotate button, the letter T there in the middle, I click the letter T. I'm going to do that again because I did it kind of fast. That letter T, enter note. In other words, annotate. Blowing up balloon is the first note I want to add. So it puts this note, which I can move by grabbing the handles and putting anywhere I want in my data. And I can drag that out of the way by clicking and dragging and putting it where I want. I'm going to put a second note on here to say where the balloon popped. And that happened, that's the first data point after it popped. I could also put it here if I want because it was somewhere between these 2 points where it popped. So this is useful for students to take notes. Again, they can save or screenshot. And I don't have time to do the activity, but I can show you a write-up for some more balloon activities in the development folder in the Google Drive. So in the Google Drive, under development time activities, there's more with that activity and balloons in this file called, where is it? It might be in a different folder. Let me check a different folder. Yes, it's in guided activities, and it's a copy of Exploring Gas Properties with Balloons. So there's a full write-up there with more than what I showed you when the balloon doesn't pop. Okay, because we're running short of time, I'm not going to get to do the other activities like the CO2 sensor, but I'll just talk briefly about it. So here's the carbon dioxide sensor. I'm going to run through a calibration just to show you quickly what it's like. When you connect the carbon dioxide sensor and you're ready to calibrate, make sure you have an empty bottle. Put it into the empty bottle. And why would you need to calibrate the sensor? Well, the first time you use it, you might want to calibrate it. Honestly, usually when you're doing experiments with middle school students, you're really just looking for changes like, did it go up or did it go down? Did it stay the same? How fast did it change? How much did it change? Those are the kinds of questions you ask. So it's up to you whether you want to calibrate the sensor or not. It should show the trend either way. But should you have the need to calibrate the sensor, here's what you do. I'm going to go and start a new experiment, and I'm going to connect the CO2 sensor very quickly. So I'm going to disconnect pressure, connect carbon dioxide, and I'm going to pick any display because it doesn't matter. When I just need to calibrate the sensor, it doesn't matter what display I pick. Calibration should be stored on the sensor automatically, so you do it once and it's good for till the months or a year or however long it seems. Right now, you'll see the CO2 concentration is at 398 or 400. You may not be able to see this because it's small. I'm going to make this larger, but even though I didn't hit start collecting data yet, there's a portion on the bottom left-hand side of the screen that is a live sample of data. So I know about what the sensor is reading before I hit start. And that's helpful for knowing when to hit start. So it says it's about 400 ppm, which tells me it's calibrated. 400 is about a normal concentration outdoors. If I wanted to calibrate the sensor, here's how. I click that live data button and I hit calibrate measurement. As long as that as long as the bottle's connected in with the sensor, all I have to do is hit the calibrate button. The menu is already set to where it needs to be. Just hit calibrate, and just like that, it's calibrated. So notice the reading is about the same. That's because I had the sensor calibrated, like the last time was 2 months ago, and it just kept its calibration. So my sensor didn't really need its calibration. Again, 400 ppm, give or take 100 ppm is about where it should be reading without having any special experiment going. About the voltage and conductivity sensor current sensor. I guess the quickest thing to say about these is if you get a negative reading, then that just means to switch the leads to the opposite sides, the opposite wires, and then you'll get a positive reading. Light sensor. For the light sensor, there are 2 ways to do a reading. There's what's called the spot sensor. So I only care about a small area. I'm going to point the spot sensor right at that one small area. Let's say I want to know information on this green dot, then I'm going to point the spot sensor at it. Okay, but if I want to know a larger area, or I want to know just what's the light level in the room, then I need to flip the sensor over to make sure that this sensor that says ambient is getting a reading from the whole room. Okay, sorry for the brief brevity of that discussion on those sensors, but I'm running short of time. I want to talk about a couple troubleshooting tips. Okay, just like any other piece of technology, if things are not working right, try restarting your system. That helps. For Chromebooks, it's especially important to always make sure that you have the most up-to-date Chrome OS before you open and run SparkView. For iOS, Apple devices, I find it's helpful to turn Bluetooth off and on if I have connection problems, and that seems to help. Or I can do what's called a hard reset, which means you hold the power button, just keep your finger down, hold it down for about 10 seconds, and then let go. And then the next time you turn on the sensor, it should reset the sensor, and that would help. That may help eliminate, it may help eliminate any issues with the sensor. Okay, here's the resources I wanted to talk about. The first link goes to the Nova Scotia version of PASCO's website. You probably will find that less useful. The resources for free labs and experiments, that's over here on the AVA website. When you go to the AVA website, here's where you should go. Go to the Resources tab, and under Resources, SparkView Spark Labs. I'm going to talk for 5 seconds about Spark Labs. When you go to use a pre-built lab file, just make sure that it has a file extension .sPKLAB. Let me show you what that looks like on my computer. So if I have a Spark Lab, you will see a file like this, and it has these dots on it, and it says SparkView Experiment. What you do is when you open this file, it will open up in SparkView, and we had some issues with the file not quite opening correctly. We think we've addressed all of those, and we have sent new files to AVA so that any issues with files should have been taken care of. So if you are downloading Spark Labs from AVA's website and you have issues with the file not opening correctly, then just get in touch with AVA. Here is their information, the phone is 877-967-2726. You can also email us. This is our teacher support team. They're here for you to help you out if you have any troubleshooting. Support@pasco.com, or here's the phone number. Or you can email me, bpugliese@pasco.com. I'm happy to answer your questions or point you to some resources if you have some specific lessons that you wanted to cover. Sorry I ran out of time, but are there any specific questions? Okay. While I'm waiting for questions, one last thing I want to point out about taking care of your sensors is the difference between the rechargeable one and the non-rechargeable one. You can tell by flipping them over. The coin cell battery one has the door on it with the dots and a notch. The battery number is right there on the door. In case the battery dies, you know exactly what the battery number is. Also, the coin cell sensors are water resistant. I drop these into beakers of water all the time and it's fine. You can tell because not only are they coin cell, but they also have the gray side. So they're more water resistant, but the USB ones less so. Be careful with water around USB powered sensors. They have plenty of points of entry for water, so please take caution there. Okay, if there's no more questions, I'm going to wrap up. Thanks for your time. And again, you can email me or PASCO Teacher Support or give Ava a call if you have any questions or would like some ideas on experiments. Thanks a lot, guys. I'm going to stop recording.